In 3.1, we're going to be looking at parallel and skew lines. So parallel lines, as you know, is when you have two lines that never intersect. So like those pens, they continue on infinitely in the same direction, and these two pens, if you were to extend those lines forever, they would go on and never intersect. But there's another way that we can have two lines not intersect. So these two pens are coplanar. So coplanar means that they are on the same two-dimensional surface. So both of these are sitting on my desk right now. The desk is a two-dimensional surface, and so these two pens are coplanar. Now, if I were to tilt one of these, if I were to angle this one slightly this way, then the pens aren't touching each other. But if we were to extend these lines onward, eventually they would come and intersect. So if we move it from being parallel at all, then they're going to intersect. But there's this idea of skew lines. So skew lines also do not intersect, but they are not parallel. So in order to make that happen, we need them to not be coplanar. So if I take one of these pens and say lift it off of the paper and then maybe turn it up a little bit, now these two pens, they're not intersecting and they're not parallel. So you can have lines not intersect and not be parallel as long as those two lines are not in the same plane. So you can see these two pens, if they're angled differently, if they're not in the same plane, they can not be parallel and still never intersect. So that's skew lines. All right, so in this picture, we have lines N and M are parallel to each other. Now it's a little hard to see here, but there's these little triangles drawn on these lines here, and these mean that the lines are parallel to each other. So that's the notation that we use for parallel. So we can say that lines N and M are parallel. We also have a symbol for when we're writing out parallel things. We use just two lines that are parallel to each other. So we can say M and N are parallel to each other just by doing that. All right, if we look at lines M and K, those are skew lines. So M is this line right here, K is this line right here. So we've got one line going straight up and down, and then one line kind of going across like this. So these lines are skew. They're not parallel and they don't intersect. And then if we look at planes, T and U, so these two planes are parallel planes. Imagine two sheets of paper, or maybe my hands kind of being parallel to each other. They can be parallel, just like lines can, as long as they don't intersect. All right, so let's look at this example one. We've got a picture of a box here, and we're going to look and see if we can find some different things in relation to point A. So it says, identify relationships in space. Think of each segment in the figure as a part of a line. Which line or planes contain point A and appear to fit the description? So let's say a line that contains point A and is parallel to CD. So CD is this line right here. We want one that contains this point right here, that's point A, and is parallel to point DC. Well, I think it's best if we look at an actual cube. So we could say line DC is maybe this line right here, and point A is this point right here. So if we want a line parallel to this line that goes through this point, well, it's going to be that line right there. So that would be line AB on the picture. So say A and B, and then draw a line above it to indicate that we're talking about a line. If we want a line skew to CD that goes through point A, so again, we're talking about this line and this point right here. Well, if we want a line skew to this one and that goes through this one, well, it's going to have to not be parallel but also not intersect. It's going to have to be this line right here going down the side. So if we look at these two lines, you can see that they are not going to touch and they are also not parallel to each other. So that's going to be AH, this one right here. All right, line perpendicular to CD that goes through A. So if it's perpendicular, it's going to have to touch. So CD again is this one. Point A is right here. So we want a line perpendicular to CD that goes through point A. It's going to be this line right here. You can see my fingers make a perpendicular angle, and also it goes through this point right here. So that's going to be line AD. And then if we want a plane parallel to EFG, Well, plane EFG, that's the bottom plane. We have these 3 points here, so that's going to be the bottom of the cube. And then if we want a plane parallel to that, well, that's going to be the top of the cube. So if this is the bottom of the cube, then the plane parallel to that is going to be this other green one here. So we could say plane ABC would work. So again, when we're naming planes, we just name 3 points on that plane. All right, postulate 13. This is called the parallel postulate. So if we have a line, say this line right here, and a point not on that line, say point P, there is one and only one line parallel to this line that goes through point P. So we can say that in mathematical terms by saying exactly one. So we say there is exactly one line through that point, no more, no less. So there is exactly one line through point P that is parallel to line L. Perpendicular postulate is basically the exact same thing, but with perpendicular lines. So if we have a line and a point not on that line, there is one and only one, or exactly one line perpendicular to that line that goes through that point. So that is the parallel postulate and the perpendicular postulate. All right, example 2. Identify parallel and perpendicular lines using this diagram. Now there's some markings on the diagram that we're going to want to pay attention to as we're going through this. One of them, again, is a little hard to see on this picture, but we've got these triangles. Those triangles mean that these lines are parallel to each other. Now we've also got this right here telling us that we've got a right angle. Okay, so part A. Name a pair of parallel lines. Well, we've got the markings here and here indicating that this line is parallel to this line. So let's say that line AB is parallel to line CD. If we want some perpendicular lines, well, we've got a right angle right here. We can say that those lines are perpendicular. So we could say that line AB is perpendicular. Again, that's upside down T, that's the perpendicular symbol. So we could say line AB is perpendicular to line CA. And part C, is line AB parallel to line BC? Well, no, they intersect right here. So if the lines intersect, then they cannot be parallel. So being parallel means that they do not intersect. So no, that is not the case. Right, now we're going to look at some names. We have special names for certain angles when you have some intersecting lines. So first of all, let's talk about the word transversal. So transversal is what we're going to, a transversal is what we're going to call a line that intersects two other lines. So if we have any two lines, say this line, and then we have a line going through those two lines, we call that a transversal. So it's a line that intersects two or more coplanar lines. Again, coplanar just means that they're all on the same two-dimensional surface. Okay, so we've got, again, different names for the different parts of these angles that are formed. So we use the term corresponding angles for angles that are kind of in the same spot in each intersection. So if we look at this intersection and this intersection, the top right of each spot, the top right of each intersection, we can, since those are kind of in the same spot of the intersection, we call those corresponding angles. So we would use the same word for the two angles, say in the top left spot of each intersection. Those are corresponding angles. The two angles in the bottom right spot of each intersection, those are corresponding angles. And then also in the bottom left of each intersection, those are corresponding angles. So corresponding angles are angles that are kind of in the same position of two different intersections of lines. Okay, if we have angles between the two lines on different sides of the lines, so say angles 4 and 5 here, these are between the two lines that we're talking about. So this is the transversal. The line by itself is the transversal. And so the other two lines that it's the transversal intersecting, the angles we're talking about are between those lines. So we call those interior angles because they're on the inside. Now, since they're on different sides of the transversal, we call them alternate interior angles. So alternate being, different, one on each side. So these are called alternate interior angles. So again, interior because they're between the two lines that are being cut by the transversal, and alternate because one angle is on each side of the transversal. Okay, so then we could have exterior angles. If we can have interior angles, then we could have exterior angles. So again, the transversal is cutting the other two lines, and these two angles are outside of those two lines. So exterior means on the outside, and again, they're on different sides of the transversal, so we call these alternate exterior angles. There we go. And we've got several pairs, or two pairs, I guess, of these as well. Same with alternate interior angles. So, go back to alternate interior angles, we could have said that this angle right here and this angle right here, that these are alternate interior angles. Similarly, we could say that this angle right here and this angle right here are alternate exterior angles. All right, the last one we're going to look at is consecutive interior angles. So interior because they're between the two lines being cut by the transversal, and consecutive because consecutive means kind of one after another in a row. So these are not on different sides of the transversal, they're on the same side of the transversal. So these are what we're going to call consecutive interior angles. All right, example 3. We're just going to start identifying some of these things that we just talked about. So let's look at all the pairs of corresponding angles. So remember that corresponding angles are angles that are in the same position of the intersections. So if we look at the top left of each intersection, that's angles 1 and 5. So those are corresponding angles. If we look at the top right of each intersection, so angle 2 and angle 6, that's another pair of corresponding angles. And if we look at the bottom left of each intersection, angle 3 and angle 7, that's another pair of corresponding angles. And last, if we look at the bottom right spot of each intersection, got angle 4 and angle 8, so that's another pair of vertical angles, corresponding angles. All right, alternate interior angles. So again, now the horizontal line is the transversal. That's the one cutting through the other two lines. And so if we're looking at interior angles, that's going to be between the two lines here. So between this line and this line, that's going to be the inside here, the interior. So 2, 4, 5, and 7, those are all interior angles. And then 1, 3, 6, and 8, those would all be exterior angles. Okay, so if we're looking for alternate interior angles, a pair of alternate interior angles, these are going to be angles that are between the two lines and on different sides of the transversal. Again, the horizontal line here is the transversal. The transversal is the one that cuts through the other two lines. So 2 and 7, those are interior angles, and they are also on alternate sides of the transversal. So we could say that angle 2 and angle 7, that's one pair of alternate interior angles. There's another pair though. The other pair would be angles 4 and 5. So angles 4 and 5 are on different sides of the transversal, and they are between the two lines being cut by the transversal. Alternate exterior angles, again, these are going to be outside of the two lines and on different sides of the transversal. So if we look at, say, angle 1 and angle 8, one's on top, one's on bottom of the transversal, and they're outside of the two lines. So that's a pair of exterior angles. So angle 1 and angle 8. Then we could look at, say, angle 3 and angle 6. Those are also outside of the two lines. And angle 6. And they're on alternate sides of the transversal. Last one we're going to look at is consecutive interior angles. So consecutive, again, means one after another. So these are going to be actually on the same side of the transversal. And interior means between the two lines. So the two lines, again, are here. So the interior angles are 2, 5, 4, and 7. And so if we want consecutive interior angles, those are going to be interior angles that are on the same side of the transversal. So in this case, if we look at the two angles on the top of the transversal, 2 and 5, That's a pair of consecutive interior angles. Another pair of consecutive interior angles would be 4 and 7. Or I guess I should say the other pair. There's only one other. And there you have it.